So this concept of optimization is probably one of the more applicable ones that you'll learn this year, especially if you're going to be a business major or something like that. Any kind of major or job where you would want to find the most or the least of something. Maybe the largest package that will fit a certain thing, or the smallest package that will fit a certain amount of square inches or cubic inches, square inches of surface area or cubic inches of volume. For instance, if you work for the post office, it's to your advantage to have smaller boxes, but there are many ways you can ship a package. So maybe you would want to have the smallest box, smallest surface area for the largest amount of volume. So that's what optimization is. A very simple example of optimization would be maybe if you had a football being thrown and you wanted to know what is the highest that this football goes. That's a concept you've already learned, and that would be a max. And you've already learned that the derivative is 0 at every max, or derivative is undefined, but most maxes the derivative will be 0. And that concept is going to come in big for this lesson today. You'll want to get yourself an equation that relates all the variables. So let me just start with an example. Let's say you're a rancher or something and you go out and you buy a mile of 4-foot fence or something like that, some kind of paneled fence, and you want to make some sort of an enclosure for your animals, and you wanted to have the maximum amount of area possible. See, because you could make a pen that looked like this, and maybe you would have it maybe like 1 foot by 1 foot over here by everything that's left on this way. That of course wouldn't be very nice for your animals. Or you could maybe start to make it more of a rectangle, or you could maybe make it a square, or maybe go the other way with it and have it really tall but not very wide. Okay, so you're wanting to make a rectangular kind of pen, and you want to know what are the length and the width that will give you the maximum area. So the first thing you're going to start out with is what we call a primary equation, or in other words, the optimized equation. Okay, and that would be area is length times width in this case. See, we got ourselves a width and a length. Length times width will give me area. I also know that I have a mile of fence. That's important because I have 5,280 feet, and that's going to equal my perimeter, you know, all the way around, which is 2 L's and 2 W's. Okay, so here are the steps for optimization. Number 1, you need to identify which equation is going to be optimized, and that would be this one. And step 2 is to use the other to eliminate a variable. It's just going to make taking our derivative a little bit easier if I go ahead and instead of writing an L here, maybe I solve this other one for L and I write what L is equal to. Like L is equal to 5,280 minus 2W over 2, which is the same as 2640 minus W. Divide both of these by 2. Okay, so I'm going to come up with a very similar equation to this one, except now my area equation only has W's in it. See, I traded this L for what L is the same as. That's algebra 1 substitution. This is going to make my life a lot easier when I'm taking the derivative. See, because this area equation right here will tell me all the different areas for all the different widths that are possible. One of those areas is the maximum area, and the other ones are just other areas that I can find. So we know that at maxes or mins, the derivative is 0 or undefined. This derivative is never undefined. So if I take my derivative is set this equal to 0 and solve. So I know that my width is 1320. So I know that one of my dimensions is 1320. Well, how do I find my other dimension? Well, I need to go back up here into one of these two equations. I don't know what my area is at that 1320, but I do know that if my width was 1320, then I can use this one. 2 times 1320 is 2640. Subtract this over here. So solving for L gives me another 1320. So that tells me that a square would give me the most amount of pasture land on the inside of this rancher's little pen here for his animals. Now, sometimes you'll have, it's very common to say I'm going to use a river and I'm going to make a fence that looks like this. So my secondary equation, which is the one that's not my primary, wouldn't be 2 L's and 2 W's. It would be 1 L and 2 W's equals 5,280 if I had a river here. So sometimes you see cattlemen making a fence along a river so they can save some fence. So your area is still length times width, but your perimeter is 2W plus L. So sometimes your primary and your secondary equations will change, but the process that's right here will be exactly the same.